Welcome back, students. This is the session 11 from the playlist of electrostatic potential and capacitance, and the topic for this session is equilibrium condition between two capacitors. So in order to explain to understand this topic, I have taken one very simple question, and the question here is 2 microfarad capacitor is charged to a potential difference of 10 volt. The battery is then removed, and this capacitor is then connected to an uncharged capacitor of 8 microfarad, which is shown in this figure. The charge in C2, that is in the capacitor C2, in the equilibrium condition is, so there are 4 options given here and we have to find the correct one. Now the equilibrium condition between the two capacitor is when the potential difference across both the capacitor is the same. So in the first case, this 2 microfarad capacitor, that is C1 capacitor, is connected to a battery of 10 volts. So now this 2 microfarad capacitor is charged to a potential difference of 10 volts. So when it is charged to a potential difference of 10 volt, then the charge on C1, that is the charge on this C1 capacitor, will be equal to Q. Now Q is equal to C into V. The capacitance of this capacitor C1 is 2 microfarad into 10, which is equal to 20 microcoulomb. So this is the total charge on this 2 microfarad capacitor when it is charged to a potential difference of 10 volts. Now here in this figure you can see that there are 2 switches. So in the first case, this switch S1 is closed, and when this S1 is closed and this S2 is open, so when this S1 is closed, then this capacitor C1 will be charged to a potential difference of 10 volts, and when it is charged to a potential difference of 10 volts, then the total charge on C1 capacitor will be equal to 20 microfarad. Now in the second case, now this battery is removed and this capacitor is now connected to an uncharged capacitor of 8 microfarad. That is, this switch S2 is now closed. Now when this switch S2 is closed, then the equilibrium condition will be attained when the potential difference across C1 and the potential difference across C2 is the same. In the equilibrium condition, the potential difference across C1 will be equal to the potential difference across the capacitor C2. Now we know that this Q is equal to CV. Now since the potential difference across C1 is equal to the potential difference across C2, so in that case we can say that since the potential difference across these two capacitors is the same, so we can say that Q is directly proportional to C, or we can simply say that Q1 upon Q2 will be equal to C1 upon C2, where C1 is the capacitance of this capacitor and C2 is the capacitance of this capacitor. So it can be now C1 upon C2 with C1 is equal to 2 and C2 is equal to 8, so this is equal to 1 by 4. Now now we have to find the charge in C2 in the equilibrium condition. That is, we have to find the value of Q2. So from this equation, that is Q1 upon Q2 is equal to 1 by 4. So it implies, now the total charge on this capacitor C1 when it was charged to a potential difference of 10 volt is equal to 20 microfarad, and by the law of conservation of charge, this 20 microcoulomb will be distributed in these two between these two capacitors. And how it will be distributed? See here, Q1 upon Q2 is equal to 1 by 4, and the total charge which was on this capacitor C1 is equal to 20 microfarad, and this total charge will be not distributed between C1 and C2. So total charge is what? That is the total charge on this, let us say this capacitor Q1 plus the total charge on the capacitor Q2, which is equal to Q2, and this will be equal to 20. Q1 is the total charge on this capacitor, that is C1, and Q2 is the total charge on the this capacitor C2. Okay? When C1 and C2 were connected to each other by closing this switch S2. So now from this equation, since I have to find the value of Q2, so I will be substituting the value of Q1, which is equal to Q2 upon 4 from this equation. So Q1 is equal to Q2 upon 4 plus Q2, which is equal to 20. So it implies that 4Q1 plus Q, this is equal to 5Q2 divided by 4, which is equal to 20. Or we can simply say that 5Q2 is equal to 80, or Q2 will be equal to 16 microcoulomb. Q2 will be equal to 16 microcoulomb. So our correct option is the alternative A, that is 16 microcoulomb. So in this question, the only important thing which you all have to remember is that in the equilibrium condition between the two capacitors, this is going to happen only when the voltage, this potential difference across those two capacitors is the same. And based on this concept and by using the law of conservation of charge, we were able to find the charge on this capacitor C2. So thank you very much for joining this session, and in the next session I will be coming up with a different type of a question, but the topic will be capacitance. So till then, have a nice day. Bye.